Welcome to the Techlearners. In today's lesson, we will talk about some another program based on the recursion. In the previous lesson, we had seen how we can calculate factorial using recursion. And today, let's talk about how we can calculate or how we can print the Fibonacci series using the recursion. Let's have a quick look on the recursion. Recursion in Java is a process in which a method calls itself continuously, and the method which calls itself is called recursive method. While defining the recursive method, we need to consider two things. One, the base case, which is a small problem where recursion comes to an end and makes it a finite problem. And second is the recursive case, which is the general case where we keep calling the function or we keep calling the method itself. So now we can see that the recursion are of two types, finite and infinite. A finite recursion where the recursion comes to an end after some condition, as we had seen in the previous video, that factorial of a number comes to an end when it reaches to 1. So the other side is the infinite recursion that never comes to an end, so it will not have this base condition. So let's talk about how we can print the Fibonacci series using the recursion. First, let's talk about what is a Fibonacci series. The Fibonacci series is a series whose elements are generated by the sum of the previous two elements. As we can see, this is the first element, this is the second element, and if we add these two elements, then we get the third element. So this is 0 plus 1, we have 1. Then if we add these two elements 1 and 1, then we get the next element 2. And if we add this 1 and 2, we'll get the next element 3. If we add 2 and 3, we get the next element 5. If we add 3 and 5, then we get the next element as 8. So this is a Fibonacci series. So what we need to do is we need to define a function or a method to sum two elements and print the result, and we can call that function again and again to complete our Fibonacci series. So when we pass 0 and 1 in the same function, it will sum 0 and 1 and print 1, and again we will call the same function and we will pass 1 and 1, and then it will sum 1 and 1 and will give us the 2. Then again we will call the same function and we will pass 1 and 2. This will sum 1 and 2 and will give us 3. Then again we will call the same function and we will pass 2 and 3. So it will sum 2 and 3 and will print 5. Yes. So let's see the Java program and understand how this Fibonacci series can be printed with the help of the recursion. So here is the simple program to print Fibonacci series using the recursion. We have taken three variables, n1, n2 and n3. So n1 and n2 will be the first two elements, and n3 will contain the sum of the previous two elements. Here I have defined a function. This is the recursive function. As you can see, this function is calling itself. So here you can see in the definition of this print fibo, it is calling the print fibo. So this is a recursive method. As a parameter, we have given a count into this that will check whether we have printed all the elements into the series or not. So now this is the base condition. If count is greater than 0, then we'll keep calling. So this is the general condition right now. If the count is still greater than 0, that means we have to print more elements. So we'll continue that we'll sum the previous two elements n1 and n2, and this sum will be printed. And yes, the next and important part in the Fibonacci series, we will shift the elements. So the n2 will be shifted to n1 and n3 will be shifted to n2. So just to pass these two elements again into the function. So if the first two elements are these, so if this is n1 and if this is n2 and if this is n3, then in the next pass we need to make this n1, this n2 and this n3. So this is a shifting we need to do. We need to perform this shifting. This is done by the swapping. So n2 will be stored in n1, entry will be stored in N2, and then when we call the function the new entry will be calculated by the sum. So we have printed this entry, and then again recursively we have called the same function with count minus 1. So once again this function will be called and the condition will be checked until this is greater than 0. This entry will be calculated and again shifting will be performed. So this is how the recursive method is functioning, or how it is making the call. And once the count is 0, we will exit from this condition. This will behave as the base condition or as the termination condition. So now let's see how we can call this. Let's say if you want to print some 10 elements, then so we'll first print the n1 and n2, and then we'll call the function with count minus 2. Why count minus 2? Because we have already printed first 2 elements. So we'll call this function count minus 2. So this count will have 8, and we'll compare that 8 is greater than 0. This is true. The entry will be calculated with n1 plus n2, that is 0 plus 1. This will be 1. Now this n2 will be stored in n1, n3 will be stored in n2, and so on. This will keep calling the function, and the recursion will print all the elements of the Fibonacci series. So let's compile this program and see the output, whether we have these elements of the Fibonacci series. We had asked it to print 10 elements. So let's see. So we have 0, 1, 1, 2, 3, 5, 8, 13, 21 and 24. So these are the 10 elements of the Fibonacci series, and we have printed these with the help of the recursion. I hope you have understood the concept of the recursion. In the previous lesson we talked about how finding out the factorial. Here we talked about printing the Fibonacci series both with the help of the recursion. If you have any question, feel free to ask your question into the comment box, and like the video, subscribe the channel for more such videos, hit the bell icon if you want to get notifications. Thank you so much.